Hi guys, welcome back to today's video. Ever since Apple launched its 35 watts dual USB-C charger, more and more brands have released their own similar products. And today we got our hands on the first dual USB-C power adapter from DJI. So let's take it apart to check out its internal components and see if it's up to pair with Apple's charger. The power adapter comes with a detachable power cord and is a 2-prong US plug. Length is about 70 cm. It adopts a black square design, the matte shell can reduce fingerprints, and the edges are chamfered. The DJI is engraved on the top center, and the overall design is very similar to the MSI power adapter we just tested and took apart. There were two USB-C output ports on the same side, marked with C1 and C2 next to them, and a 2-prong socket is on the other side. The specs info is printed on the bottom, model is CDX265-100. It can support input of 100 to 240 volts, 50 or 6 Hz, 2.5 amp. The USB-C 1C2 can provide up to 100 watts output, and when charging two ports at the same time, the power can be divided into 82 watts and 18 watts. The manufacturer is Honor Electronic. It also has passed multiple certifications. The size of the adapter is about 73.6 by 70 by 32 mm. Compared with Apple 96 watts charger, the size is slightly smaller, and the total weight is about 278 grams. Connected to Teardown Power ZKM002C, it shows the USB-C 1 supports FCB, SCB, AFC, QC 3.0, PD 3.0, PPS, QC5, Apple 2.4 amp, and Samsung 5V 2 amp protocols. And it also supports 5 fixed PDOs of 5 volts, 3 amp, 9 volts, 5 amp, 12 volts, 5 amp, 15 volts, 5 amp, 20 volts, 5 amp, and a set of PPS. The supported protocols and PDOs of USB-C 2 are the same as USB-C 1, so both can support up to 100 watts. After the brief introduction, let's take it apart and check out the internal components. As always, use a spatula to pry along the gap and open it up. The entire PCBA module is wrapped with two pure copper heatsinks. They are fixed to the plastic case on both sides with a huge amount of white silicone adhesives. The input socket is connected to the module through two wires. Remove the heatsinks. We can see that there is a piece of black mylar sheet under it. The front of the PCBA module is fixed with a large number of black silicone adhesives, and there is a mylar sheet insulated the low voltage buck PCB and the high voltage components. And those heating chips on the back are also covered with a lot of silicone adhesives for heat dissipation. After cleaning up the PCBA module, we found the input filter components, PFC bus inductor, filter capacitor, and LLC transformer around the front of it. And the controller, secondary synchronous rectifier circuits, and many MOSFETs are on the back. ChargerLab found it adopts LLC topology and is equipped with PFC circuit. And the power supply solution is from NXP. This is a red input fuse, 250 volts, 5 amp. The first common mode choke next to it is wound with magnet and insulated wires. The safety X2 capacitor is from SCC, 0.33 microfarad, and the NTC thermistor is used to suppress surge current. The second common mode choke is wound with copper wires and insulated with yellow tape. The bridge rectifier is wrapped with another small pure copper heatsink, which is pretty rare. Those two red film capacitors are identical, 0.47 microfarad, 400 volts. And the toroidal coil inductor in the middle is insulated with yellow tape. The primary PWM controller is from NXP, which is the digitally configurable 2-in-1 controller of LLC topology plus PFC circuit. This is the electrolytic capacitor that powers the primary controller, 47 microfarad, 50 volts. And the PFC boost GaN FET is from GaNext, 650 volts, 240 milliohm. The sampling resistor next to the GaN FET adopts 2512 package. It's used to detect the switching current of the PFC circuit with a resistance of 75 mA. The smaller PFC boost inductor adopts ATQ24 magnetic core. The PFC boost MOSFET is from WeEn, which is an ultra-fast recovery diode and adopts a TO252 package, 600 volts 9A. These three blue electrolytic capacitors for input filtering are from Chengxing, 18 microfarad, 420 volts. And this bigger black one is also from Chengxing, 27 microfarad, 420 volts. So the total capacity is 81 microfarad. Those two same LLC MOSFETs are from Oriental and adopt DFN 5x6 package. They can form a half bridge, 700 volts, 360 mA. This is a black resonant capacitor, 0.033 microfarad, 630 volts. And this bigger resonant inductor adopts ATQ17 magnetic core. The transformer adopts ATQ2716 magnetic core and is insulated with heat-resistant tape. These 6S70Y capacitors are from Holy Stone, which can be divided into 3 groups, and each group is connected in series to increase the withstand voltage. The white optocoupler is used to feed back the output voltage. The secondary synchronous rectifier controller is from NXP, which has 2 built-in drivers for LLC topology. These 2 synchronous rectifier MOSFETs are from WAYON and adopt PDFN 5060 package, 80 volts, 4.3 mA. This is the solid capacitor for output filtering, 1000 microfarad, 25 volts. The protocol chip is from INJOINIC, which controls the output of 2 USB-C ports. Firstly, let's check out the USB-C 1 circuit. The synchronous buck controller is also from INJOINIC. Its built-in switch frequency is fixed at 135 kHz and supports 5A output current. Those 4 MOSFETs are marked with B3006. The 2 output V-bus MOSFETs are on the left, and the 2 secondary synchronous buck MOSFETs are on the right. Next, we have the components of USB-C 2 circuit. This is the identical synchronous buck controller from INJOINIC, and 4 MOSFETs are also marked with B3006, which has the same function as USB-C 1 circuit. Well, that's all components of this DJI 100W USB-C power adapter. The 3 thick pure copper heatsinks and a large number of silicon adhesives inside the adapter are different from Apple 35 fast charger's thermal pads, but both of them can provide us with excellent heat dissipation performance. So if you own a DJI drone, this power adapter will definitely give you a decent charging experience. Okay, that's all for today's video. Feel free to click the corners to check other videos for power adapters. Please drop a like, leave your comments, and subscribe to us. See you in the next video. Bye!